All right, let's go. Number 10. The island before Santorini. Santorini is a ring, Thracia, and a splinter of rock called Aspernici curve around a flooded basin about 11 kilometers across. In the middle of it sit two small black islands of raw lava that were not there 3,000 years ago. Every guidebook explains that. Shaped the same way. One eruption in the late Bronze Age blew the center out of a cone. The explanation is not wrong. It is nowhere near complete. In 2016, Konstantin Athanasius, Timothy Druitt, and Paraskivi Nomikou went at the caldera walls themselves. Their method was cosmogenic chlorine-36. The isotope builds up in rock exposed to the sky and stops the moment that rock is buried. At least the northern half of that basin was already a caldera before the Bronze Age eruption began. There had been an earlier catastrophe. The Cape Riva eruption, 21,800 years ago, had already opened the island and let the sea in. What stood there in the Bronze Age was not a cone waiting to fail. In 2018, David Carrottson and colleagues, working with Druitt and Nomikou, rebuilt the island on paper. They describe a ring-shaped island wrapped around a flooded bay. Inside that bay stood a second island, a volcano that had been growing out of the water for something like 20,000 years, with a volume between 1.5 and 3 cubic kilometers. Geologists call it Prehistoric. Nobody knows what the people who could see it from their doorways called it. Those people left a town. Spiridon Marinatos began digging at Akrotiri in 1967 and uncovered 3-story buildings, drainage, and wall paintings of monkeys, swallows, and boats, all of it packed in ash. Furniture had rotted and left cavities, and plaster poured into them brought back the shapes of beds and tables. Christos Doumas took the excavation over in 1975. In more than 50 years of digging, nobody has found a body in that town. The eruption itself was remeasured recently, and the number came down. In 2023, Jens Karstens and colleagues published a revised total in Nature Communications. About 34.5 cubic kilometers of dense rock, against earlier estimates that had run past 80. But here is where the arithmetic stops being volcanology and turns into geography. A large part of what went up had been standing above the waterline. The eruption destroyed the island in the bay outright, took a section of the ring with it, and left a hole in the sea. The sea answered on Crete. At Palikastro, Hendrik Bruins, Johannes van der Plicht, and Alexander McGillivray traced a deposit 300 meters inland. It holds Santorini ash, smashed pottery, plaster, and animal bone tipped over in one direction. That is a tsunami recorded in rubbish. In 2022, Vasif Sahoglu and Beverly Goodman Chernoff reported the first known victims of the eruption. They were not on Santorini. They were at Çeşme Baglararasi on the Turkish coast, a young man and a dog, caught in the debris of the wave. The unsettling detail is the distance. That is more than 200 kilometers of open water from the volcano. The date is still argued. Radiocarbon points to the early 1600s BC, the archaeology of the Eastern Mediterranean, to something perhaps 80 years later, and the newest tree ring work has not closed the gap. What is not argued is the absence. Ferdinand Fuchs, working the pumice quarries on Thracia in 1867, found the skeleton of a person crushed under a collapsed roof. That is one individual on the wrong island. The disturbing part is not that the people of Akrotiri died. It is that nobody can show where they went. The island they saw from their windows was taken apart down to the waterline, and everything we know about it was read out of the rock a very long time afterwards. Number 9. The island the Bahamas used to be. In 2004, a cave diver named Brian Kakuk dropped into a blue hole in the pine forest of southern Abaco in the northern Bahamas. Sawmill Sink is a shaft in the limestone that runs about 46 meters down. Diving it means passing through layers. Fresh rainwater sits on top. Then, somewhere between 9 and 14 meters, comes a dense bacterial layer producing hydrogen sulfide, which turns the water the color of strong tea. Below that is salt water, perfectly clear, with no oxygen in it at all. On the debris slope under all of that, Kakuk found a tortoise shell. Nothing had eaten it. Nothing could. Below the bacterial layer, there is no oxygen. and so there are no scavengers, no fungi, and almost no decay. The peat deposits on that slope, 27 to 35 meters down, had been holding their contents the way a sealed jar holds fruit. David Stedman of the Florida Museum of Natural History and Nancy Albury of the National Museum of the Bahamas built a project around the hole. Over the following decade, it produced more than 5,000 fossils and 95 species of vertebrate. More than 50 Cuban crocodiles came out of it, some complete and still articulated. The tortoise was new to science. Richard and Shelley Franz described it in 2009 as Chelonoidis alburiorum, named for Albury. Then the fossils began returning. Things fossils are not supposed to return. In 2017, Christian Kalemeyer and colleagues published mitochondrial DNA taken from a tortoise bone about 1,000 years old in Proceedings of the Royal Society B. Ancient DNA survives in cold, dry places. This came out of a warm, wet, tropical island. It was the first ancient genome we had ever recovered from an extinct tropical species. A caracara femur from the same system, 2,500 years old, later gave up 98.7% of that bird's mitochondrial genome. That is an extraordinary return from a hole in a forest floor. What makes the hole matter is not the preservation. It is the map underneath it. At the last glacial maximum, the sea stood roughly 120 meters lower, and the Bahama banks are shallow. The archipelago was not slightly larger. It covered something like 125,000 square kilometers, against roughly 13,000 today. Abaco and the Little Bahama Bank alone made one island of about 16,700 square kilometers. That island is now 1,214. 9/10 of the country we call the Bahamas is underwater. The fossils in the hole record what went down with it. Stedman, Albury, and Cook then sorted the losses by date. 39 of the 95 species no longer occur on Abaco. 17 of them, all birds, disappeared during the Pleistocene to Holocene transition between about 15,000 and 9,000 years ago. While the land was drowning, the climate was turning wetter, and the drier habitats those birds depended on were going with it. The other 22 disappear inside the last 1,000 years. That second group is the one with people in it. In 2021, Peter Van Hengstem and colleagues read a 36-meter core from Blackwood sinkhole on Abaco. Charcoal rises through it, and the forest turns from hardwood to pine at around 830 AD. That is burning. That is the arrival of the Lucayans. The attribution is chronological rather than proven. What the deposits give is a last appearance date for every animal. The haunting part is the second cluster. Everything in it had already survived the drowning. The tortoise is in that group. So is the crocodile, and so is the caracara. They came through the loss of 9/10 of their country, held on for 8,000 years on what was left, and went inside a single millennium. The shell Cook found is intact after 1,000 years for one reason. It came to rest in water that cannot support life, on the floor of a hole in a country that is mostly sea. Number 8. The guyots. Harry Hess was a geologist at Princeton. In the Second World War, he was given command of an attack transport, the USS Cape Johnson, and he did something with it that nobody had thought worth doing. He left the Echo Sounder running. The ship crossed and recrossed the Pacific, carrying troops to the Marianas, to Leyte, to Iwo Jima, and the sounder drew the bottom the whole way. What came off that roll was a profile of a seafloor nobody had profiled. It had objects in it that should not have been there. They were mountains with their tops cut off. Flat, level summits. Some of them tens of kilometers across. They stood a kilometer or more above the abyssal floor and ended in a plain. Hess counted about 160 of them between Hawaii and the Marianas. He published in 1946 in the American Journal of Science under a title that gave the whole answer away: Drowned Ancient Islands of the Pacific Basin. He named them guyots, after Arnold Guyot, whose name is on the geology building at Princeton. The logic is short and very hard to escape. One process planes the top off a volcanic island, and that is surf. Surf happens at sea level. Hess measured those plane surfaces at between about 950 and 1,750 meters below the modern sea surface, clustering near 1,460. He had no samples. He says so in the paper and recommends that somebody go and get some. Edwin Hamilton did, and published the results 10 years later. Dredges came up off those summits, carrying rounded, wave-worn cobbles and the remains of shallow water animals. Later drilling turned the inference into a stack of physical detail. On Resolution Guyot in the mid-Pacific Mountains, the ocean drilling program recovered reef limestone full of rudist bivalves and corals, cut through with caverns, sinkholes, and hardened crusts. That is what rain does to exposed limestone. The summit is now about 1,320 meters down. On Alison Guyot, the same program recovered a crocodilian tooth about 110 million years old. On MIT Guyot, it recovered the shells of charophytes, which are algae that live in fresh water. It also recovered a soil horizon, 9.5 meters thick, lying on top of a lava flow. Soil. 9.5 meters of it, on a mountain 1,400 meters under the Pacific. And then, the arithmetic behind all of it turned out to describe every ocean on the planet. Oceanic crust is hot when it forms, and it cools for the rest of its life. Cooling rock contracts, gets denser, and rides lower. Barry Parsons and John Sclater set the relationship out in 1977. The rule is simple. Depth increases with the square root of the age of the seafloor beneath. Every volcanic island in every ocean basin is standing on a slab that is slowly sinking underneath it. And we can now put a number on the rate. Charles Darwin had reasoned his way to a version of this in 1842 from coral atolls and had asked in print for somebody to drill one. In 1952, the United States Geological Survey did on Enewetak in the Marshall Islands as part of the site work for the nuclear tests. The hole on Perry Island passed through shallow water limestone laid down in the Eocene and struck basalt at about 1,267 meters. A second hole on the islet of Alugalab hit basement near 1,400. That is a very strange object to find under an atoll. A reef more than a kilometer thick, standing on a drowned volcano, built by animals that can only live in the top few tens of meters of the sea. It grew upward for tens of millions of years, at exactly the rate the ground beneath it sank. Alugalab is worth a last sentence, and it is a brutal one. The hole drilled there confirmed a process that takes 100 million years to remove an island from the world. On the 1st of November of that same year, Alugalab was the ground zero of the first hydrogen bomb test. By the following morning, the island was not there. Number 7. The Kerguelen Plateau. In December 1998, the drill ship Joyd's Resolution sailed into the southern Indian Ocean on the 183rd leg of the ocean drilling program. Frederick Frey of the Massachusetts Institute of Technology was one of the chief scientists, with about 25 researchers aboard. They were there to drill a piece of seafloor. That is not really seafloor. The Kerguelen Plateau covers something like 1.2 million square kilometers. It stands 2 kilometers above the abyssal plain around it, and sits mostly 1 to 2,000 meters below the surface. 3 specks of it are above water: Kerguelen, Heard, and McDonald. Everything else is a submerged tableland, roughly 3 times the area of Japan. It was built by a hotspot that has been erupting for something like 145 million years, in pulses. The southern plateau went up between about 120 and 110 million years ago. The central plateau followed at around 100 million. Under the water, it is basalt, kilometers of it, and the expectation was straightforward: lava, then ocean, then sediment. It does not even contain all of itself. Broken Ridge, now a long way off to the northeast, and mapped as a separate feature, was part of the same structure until seafloor spreading pulled the two apart around 43 million years ago. 2 names on a chart, 1 broken object. The expedition drilled 7 basement sites, 5 on the plateau and 2 on Broken Ridge. At Site 138 on the central plateau, the core came up wrong. Above the lava flows, the drill passed through sediments, and in the sediments were fragments of wood, seeds, spores, and pollen, roughly 90 million years old. The wood was identified as Araucarian and cypress family conifer, which are the same kinds of tree standing on Antarctica at the same period, in a world where the far south carried forest instead of ice. That is not a marine deposit. That is a forest floor, 2 kilometers under the Southern Ocean. Then the ship moved to Alan Bank on the western edge of the plateau and drilled Site 1137. Between two lava flows, it recovered about 26 meters of river conglomerate, rounded pebbles sorted by moving water, and among them clasts of garneted biotite gneiss. Gneiss of that kind is continental rock. It does not form in an ocean volcano, and it does not travel far. It was already lying there when the lava arrived, which means a fragment of continent went out into the Indian Ocean when India, Antarctica, and Australia came apart, and the hotspot built a plateau on top of it. What makes this genuinely extraordinary is the scale that follows. The southern plateau is reconstructed as an island of roughly 500,000 square kilometers, with high ground standing 1 to 2,000 meters above the sea. That figure is a reconstruction, drawn from the spread of lava that erupted in open air and the soils that formed on it. It is not a measured coastline, but the direction of the error is not in doubt. Something the size of a large country was above water in the middle of the southern Indian Ocean. It was not there briefly either. Parts of the plateau were dry land across 3 separate intervals between roughly 100 million and 20 million years ago. Sections of the southern plateau appear to have stayed above the sea for as much as 50 million years after their volcano shut down. For comparison, the entire history of our own genus is under 3. Then it went under. The ocean closed over all of it except 3 specks, and the largest thing standing on any of them is an active volcano on Heard Island. What we have of that forest is a set of wood fragments in a core liner, cataloged by depth and stored in the dark. No animal remains have come out of those layers. Whether anything walked under those trees, whether anything ate those seeds, whether the island had rivers that anybody would have needed to name, is not recoverable and probably never will be. The haunting part is how close it still is. Somewhere under 2 kilometers of the Southern Ocean, there is ground that trees grew out of, and no human being will ever stand on it. Number 6. The island that ran out of water. St. Paul is one of the Pribilof Islands, sitting on its own in the Bering Sea about 400 kilometers from the Alaskan mainland. 110 square kilometers of volcanic rock, fur seals, crab boats, and fog. There are no trees on it. There is also, in its caves and its sediments, a great deal of mammoth bone. In 2016, Russell Graham of Pennsylvania State University and 15 colleagues published the date those animals died out in the Proceedings of the National Academy of Sciences. 5,600 years ago, give or take 100. Set that against the mainland. Across Asia and North America, the mammoths were essentially finished between 14,000 and 13,200 years ago. The St. Paul population was still standing when the first cities were going up in Mesopotamia. The precision is the part that took work. The team used 5 independent indicators. 3 of them are dung fungi, Sporormiella, Sordaria, and Podospora, whose spores can only reach a lakebed by passing through a large plant eater first, and which vanish from the core at the same level. The 4th is sedimentary ancient DNA, pulled straight out of the mud, which stops recording mammoth at 5,650 years ago. And the 5th is a set of radiocarbon dates on 14 mammoth remains recovered from the island itself. 5 lines of evidence. 3 of them need no bones at all, and every one of them agrees. We know when that population ended more precisely than we know it for almost any extinct animal. So what kills a mammoth herd on an island with no hunters on it? There were no people on St. Paul until 1787. Nothing hunted them. The pollen in the core shows the vegetation holding steady straight through the extinction. Nothing arrived to eat them, and the plants they lived on did not fail. What changed was the island. St. Paul was cut off from Beringia between 14,700 and 13,500 years ago as the sea rose over the land bridge. It then shrank quickly until about 9,000 years ago, when it reached the size it is today, which means the shrinking stopped 3,000 years before the animals did. The answer was in a lake. Lake Hill sits near the middle of the island, and the team took a sediment core from it covering the whole period. Magnetic susceptibility, which tracks how much eroded rock is washing in, falls away, and oxygen isotopes climb between 8,500 and 5,300 years ago, which is the signature of water evaporating faster than it is being replaced. The diatoms shift from open water species to species that live along a shoreline. A salt-tolerant water flea becomes abundant. Read together, those describe a lake getting shallower, muddier, and saltier. On an island with no rivers, in the middle of a cold sea, lakes are the entire supply of fresh water. A living elephant drinks well over 100 liters a day, and there is no reason to think a mammoth drank less. The authors add one more element, and they hedge it, so this does too. Heavy animals working the edge of a shrinking pond strip the plants off the bank, break the bank down, and push sediment into the water. On that reading, the mammoths were making the last reliable water on the island worse every time they used it, which is a disturbing kind of ending. The nitrogen isotopes in their own bones shift in the same window. That is the whole mechanism, and it is a brutal one. No hunters, no collapse of the vegetation, no disease. A population fenced into 110 square kilometers by a rising sea, drinking a lake that was turning into a puddle. One other island held on longer. Wrangel, north of Siberia, is 70 times the size of St. Paul, and its mammoths lasted about another 1,600 years. In 2024, Marianne de Haske, Love Dalen, and colleagues sequenced genomes across that population's history and found it stable, not spiraling into inbreeding. Whatever finished it was sudden, and nobody knows what it was. The deepest natural lake on St. Paul today is 1.3 meters. That is the same process, still running, on an island that has nothing left for it to kill. Number 5. The continent under Mauritius. Zircon is a crystal that grows in cooling magma, usually a few tenths of a millimeter long. When it forms, it takes uranium into its structure and refuses lead. Any lead found inside it afterwards has to be the product of decay, and the ratio between the two is a clock. It is also close to indestructible. It survives weathering, rivers, burial, and even the melting of the rock that made it. In 2013, Trond Torsvik and colleagues published zircons from the beaches of Mauritius in Nature Geoscience, and the ages made no sense. One group came out older than 1970 million years. Another fell between 660 and 840 million. Mauritius is a young, volcanic island. It sits on ocean floor in the western Indian Ocean, built by the same hotspot that is under Reunion today. And there should be nothing on it older than a few million years, except that beach sand travels. The objection was immediate, and it was fair, and it was put publicly by working geologists, including Jerome Diamant in Paris. Sand arrives in ships' ballast. It arrives in imported aggregate. It arrives on the soles of shoes. A grain lying loose on a beach has no provenance at all, and no continent can be built on one, which left a clean test. Find the same crystals locked inside solid rock. In 2017, Louis Aschwall of the University of the Witwatersrand, Michael Wiedenbeck of the German Research Center for Geosciences at Potsdam, and Torsvik published the result in Nature Communications. They had sampled a trachyte plug on Mauritius, a body of lava that pushed up through the older basalts and cooled hard. Then they crushed it. 13 zircon grains came out of that rock. 10 of them dated the trachyte itself at 5.7 million years. The other 3 measured across 20 separate ion beam spots, returned ages running from 3,030 million years down to 2,552 million. 3 crystals, up to 3 billion years old, inside a rock less than 6 million years old, on an island in the middle of an ocean. The interpretation is a continent. The nearest rock of that age is in central and eastern Madagascar, about 700 kilometers west. In the reconstruction, a Precambrian fragment called Mauritia sat between India and Madagascar and was torn into strips as the Mascarene Basin opened through a series of jumps of the spreading ridge between roughly 84 and 61 million years ago. On that reading, Mauritius is a young volcano built on the wreckage of a much older landmass, and the 3 old crystals are pieces of the basement, carried up in the melt. North of the island, The Kerguelen Plateau runs away towards the Seychelles as a chain of shallow banks. On the reconstruction, those banks are the rest of the strip. What is at stake there is larger than one island. If the reconstruction holds, then continents do not only break into halves that stay above water and stay visible, they can be shredded lengthwise, and the shreds can go under and remain under, with volcanoes growing on top of them until nothing at the surface gives them away. Mauritius would then be a lid. The reading is not settled, and the strongest objection is geophysical rather than chemical. In 2016, Manvendra Singh, Ayub Kaviani, and Georg Rumker measured the crust beneath Mauritius using earthquake waves arriving from far away, a method that reads the depth at which crust meets mantle. They found 10 to 15 kilometers of crust, with a gradual boundary rather than a sharp one. The Seychelles, which is an accepted continental fragment, has 28 to 42 kilometers and a clean base. Their conclusion is ordinary ocean crust, thickened from below by the hotspot that built the island. Their account of the old crystals is that fragments of continental material can be stranded in the mantle and carried up later in magma. So the crystals are measured, and their ages are not in dispute. What they are attached to is Mauritius is on every map, in the right place, at the right size. Whatever else is down there has no coastline, no soundings, and no name that anybody used while it had a surface. The unsettling thing is the ordinariness of the container. The only pieces of it we have ever held came up inside a volcano, 3 at a time, and they are older than nearly everything on the face of the planet. Number 4. The monolith on Pantelleria Vecchia Bank. Between Sicily and Tunisia, the Mediterranean is unusually shallow. At the height of the last glaciation, with the sea about 120 meters lower, most of that shallow ground was not sea at all. The Adventure Plateau, west of Sicily, stood out as a peninsula. South of it, a scatter of banks stood as islands. That geography matters for more than scenery. At its widest, the land reached to within a few tens of kilometers of North Africa, which turns the crossing between Sicily and Africa into something a person on the shore could see across. The Sicily Channel was not a barrier then. It was a set of stepping stones. They did not go under gently. In 2015, Dario Sivilla and colleagues put numbers on the drowning. Between about 11,500 and 11,200 years ago, the sea climbed from roughly 60 meters below, present to 42. Some of those islands lost more than 80% of their area inside 3 centuries. On ground that flat, a rise of 1 meter carries the beach hundreds of meters inland, which puts the fishing camp, the shellfish beds, and the freshwater seep under salt water inside a single working lifetime. One of them is now called Pantelleria Vecchia Bank. It covers about 5 square kilometers. Its shallowest point is between 16 and 24 meters down, and it lies 60 kilometers south of Sicily. In 2015, Emanuele Lodolo of the National Institute of Oceanography and Applied Geophysics in Trieste, with Zivi Ben Avraham, published a description of something lying on it in the Journal of Archaeological Science Reports. At 40 meters depth, there is a single block of stone, 12 meters long, weighing something in the order of 15 tons, broken into 2 pieces. It has 3 holes in it. One goes right through, about 60 centimeters across, half a meter from one end. 2 more, roughly 50 to 60 centimeters wide and 40 deep, sit on opposite faces near the middle. Their conclusion was blunt. No known natural process makes that. Somebody made it. The dating needs care, and the paper is honest about it. 4 samples of shell material taken from the rock returned calibrated ages between about 37,000 and 44,600 years. That is the age of the rock and of the organisms cemented into it. It is not the age of anything anybody did to it. The figure attached to the stone in most retellings, 9,350 years, is not a measurement at all. It is the date the bank went under, read off a sea level curve. The problem is that the shaped stone is not an artifact until somebody can show the hand. In 2024, Ehud Galili and colleagues published the case against it in the Journal of Marine Science and Engineering. Their argument is precise. The rock is beach rock, which is sand and shells cemented together at a shoreline, and it matches a long ridge of beach rock a short distance away. Beach rock fractures into rectangular blocks along its bedding, which accounts for the shape. It also develops holes, waves, currents, and boring organisms cut hollows into it, and two hollows meeting from opposite faces make a hole that goes straight through. On their reading, a storm or a slope failure dropped a block off that ridge while the coast was drowning, and the radiocarbon is dating the beach rather than a builder. Then, they add the detail that does most of the damage. Nothing else has ever been found there. No flint, no charcoal, no hearth, no worked bone, nothing on the bank at all. Not one flake. Lodolo's own team went back. In 2023, they published a survey of two nearby ridges, one of them 820 meters long. Their own summary is the fairest sentence written about any of it. The data they wrote do not conclusively reveal either a natural or an anthropogenic origin. What is not in question is the island. It existed. It had a shoreline, and that shoreline is now 40 meters down. It drowned fast enough that one person standing on it could have watched the beach move inland, which is a frightening thing to be certain about when nothing else here is certain. Everything else is argument. There is a stone 12 meters long with 3 holes in it, lying on the roof of a drowned island in the Sicily Channel. The one thing we cannot recover is whether the last thing to shape it was a wave or a hand. Number 3. The Bassian Plain. Bass Strait is 240 kilometers of bad water between Victoria and Tasmania. It has wrecked a great many ships. In anything small, it is one of the more frightening stretches of sea in the world. It is also shallow. Most of it is less than 70 meters deep. Put the last glacial sea level against that number, and the strait stops existing. With the ocean around 120 meters lower, the whole floor of it was open country. A plain joined the Australian mainland to Tasmania. Sitting in the middle of that plain was a large freshwater lake. People walked across. Tasmania has been occupied for something in the order of 40,000 years. Every one of those first arrivals came on foot. What makes the Bassian Plain different from an ordinary drowned coastline is the shape of the flooding. The sea did not come at it as a single front. It got into the basin and filled it from the west over roughly 3,000 years, and the rim was covered by about 8,000 years ago. Because the floor of that basin is not level, the water took the low ground first and left the ridges standing. For something like 3,000 years, the country between Victoria and Tasmania was neither a plain nor a strait, but a set of islands with widening water between them. What that produces is not a retreating shoreline. It is an archipelago, losing members. Ridges become islands. Islands become reefs. The water did the rest. Reefs become shoals with a name on a chart and a light on top of them. The high ground at the eastern end is the Furneaux Group, and its largest island is Flinders. Robin Sims' excavation at Manillargenis Cave puts people there from about 23,000 years ago. It was a range of hills standing over a plain then. The evidence for occupation continues, thinly, through the flooding. The most recent dated material on Flinders Island is around 4,700 years old. After that, there is nothing. At the western end, Sandra Bodler's work at Cave Bay Cave on Hunter Island gives a comparable start around 23,000 years ago. It gives a different ending. The later material there is read as visits by canoe rather than residents. Sims' interpretation in her 1998 thesis at the Australian National University is that the Furneaux population was stranded. She found no evidence for seagoing watercraft in that region. Her argument is that people left on Flinders by the rising water had no way back off it. That framing has been contested, and it should be. In the 1970s, Rhys-Jones treated the Bass Strait Islands as a natural laboratory for what isolation does to a culture. The model has been criticized hard since. Bowdler has argued for a more careful reading and has documented Aboriginal presence in the islands continuing through the 19th century. In 2023, Patrick Morrison, Michael O'Leary, and Joe McDonald reframed it again in quaternary science reviews. The silence in the record, they argue, is a fact about the geography of Bass Strait, which is unusually hostile. It is not a fact about anybody's capability. In the Kimberley and in the Torres Strait, island seafaring carried on without a break. One thing needs saying plainly. because it has been got wrong for 2 centuries. Tasmanian Aboriginal people are a living community. The claim that they were an extinct race survived in official documents into recent memory. In 2023, after campaigning by the Palawa elder Rodney Dillon, UNESCO formally corrected a 1982 evaluation that had said exactly that. The Furneaux Islands, Mauritia, are home to a Tasmanian Aboriginal community now. Crown land on Cape Barren Island was returned to Aboriginal ownership in 2005. That community's presence there comes out of a 19th century history, and it should not be folded into the prehistoric record as though the two were one story. What the archaeology holds is narrower than anything built on top of it, and it sits almost entirely on the islands. Not one site has ever been published from the floor of the strait itself, and we have barely looked. The plain is down there under 60 meters of water, 40,000 years of occupation, unexcavated and unmapped. On one island at the eastern end of that plain, people were still living 4,700 years ago. The country their ancestors had walked across to reach it had been underwater for 4,000 years by then. The tops of its hills were the only ground left. Number 2, Santarosae. In 1959, Phil Orr, a curator at the Santa Barbara Museum of Natural History, was working in Arlington Canyon on Santa Rosa Island, off the coast of Southern California. 11 meters down in the wall of a gully, he found human bone, 2 thigh bones, and fragments. The bones then sat in the museum for 30 years. Nobody had a method of dating them that could be trusted. In 1989, John Johnson started again with Thomas Stafford, Haruna Agee, and Don Morris. What finally worked was a purified extraction of collagen from inside the bone, which strips out the contamination that had wrecked the earlier attempts. The date came back at 10,960 radiocarbon years, plus or minus 80. Calibrated, that is close to 13,000 calendar years. It makes the Arlington Springs individual one of the oldest securely dated human beings anywhere in the Americas. Everything we know about that person comes out of 2 thigh bones. Now, the island. Santa Rosa is one of the 4 Northern Channel Islands, with Santa Cruz, San Miguel, and Anacapa. At the glacial maximum, they were not 4 islands. They were one, and Orr gave it a name, Santarosae. Reconstructions put it at somewhere between 1,800 and 2,100 square kilometers. The 4 survivors together come to about 500. Somewhere between 70 and 75% of that island is gone, and what is left is the highest ground on it. It was never joined to the mainland. The shape of the seafloor rules that out, and at the narrowest, the crossing was still 6 to 8 kilometers of open water. Everything that ever lived on Santarosae arrived across a sea, including the elephants. Columbian mammoths reached the island by swimming, which sounds absurd until you watch a living elephant do it. Once they were there, the island did to them what islands do. Adults stood between 1.4 and 2.1 meters at the shoulder and weighed around 900 kilograms, from ancestors over 4 meters tall and several tons heavy. The dwarf species has a name of its own, Mammuthus exilis. But here is where the story stops being one crossing and becomes a rhythm. In 2015, Daniel Moose and colleagues dated a mammoth tusk out of a raised marine terrace on Santa Rosa. Uranium series put the animal between about 83,000, 878,600 years ago. That is a different glacial cycle entirely. The island has been assembling and breaking apart again and again, and elephants have been swimming out to it more than once. The best skeleton came out in 1994, after Tom Rockwell and Kevin Coulson found bone in a dune on a terrace. Larry Eigenbrod excavated more than 90% of an articulated adult male, the most complete pygmy mammoth in the world. Collagen from its femur returned 12,840 radiocarbon years. Then, in 2014, a park biologist named Peter Larramendy noticed a tusk sticking out of a stream bank. It was excavated 2 years later. It is a whole skull, and it does not fit. It is too large for a pygmy mammoth and too small for a Columbian one. Charcoal beside it dates to around 13,000 years ago, which is the same window as the man in Arlington Canyon. They overlapped. on the same shrinking island at the same time. It is a haunting thing to be able to date at all. Then the meltwater took it apart. Anacapa separated first, then Santa Cruz, then Santa Rosa and San Miguel, over roughly 2,000 years. The archaeology from that stretch is extraordinary in its own right. Daisy Cave on San Miguel runs back about 11,600 years. A Santa Rosa site published in 2020 by John Erlandson, Torben Rick and colleagues runs back about 11,700, with delicate stone crescents, barbed points, and a diet of waterfowl, fish, and sea mammals. People were working that coastline from boats while it was being taken away from them. In April 2022, the Arlington Springs remains were repatriated to the Santa Ynez Band of Chumash Mission Indians. They are out of the museum drawer and back in the ground. The Chumash are still on that coast. The island is not. The plain that man walked across. The ground the mammoths fed on. The fresh water they were both drinking is 100 meters down in the Santa Barbara Channel. What is left on the chart is only the high ground. Number 1. Zealandia. Every world map you have ever looked at has a hole in it, and the hole is close to 5 million square kilometers across. In 1995, the geophysicist Bruce Luyendijk proposed a collective name for 4 things: New Zealand, the Chatham Rise, the Campbell Plateau, and the Lord Howe Rise. His grounds were simple. They are not separate features. They are one object, and he called it Zealandia. In 2017, Nick Mortimer of GNS Science and 10 colleagues made the formal case, under a title that did not hedge: Zealandia, Earth's hidden continent. Their argument was a test with 4 parts. The thing has to stand well above the ocean floor around it. It has to be built of the full range of continental rock, rather than ocean basalt. That means silica-rich igneous rock, metamorphic rock, and sedimentary rock. Its crust has to be thicker and slower than oceanic crust, and it has to have clear limits, over an area large enough to count as a continent rather than a fragment. Zealandia passes all 4. It covers 4.9 million square kilometers. 94% of it is underwater. Its most common elevation is about 1,100 meters below sea level. What is dry is New Zealand, New Caledonia, and a scattering of small islands. That comes to roughly 286,000 square kilometers, which is under 6% of the whole. Aoraki, Mount Cook, at 3,724 meters, is the high point of a continent that is otherwise submerged. It carries a Maori name as well, Te Reo Maui, the hills and valleys and plains of Maui. The truly unsettling part is not that Zealandia is under the sea. It is the question of whether it was ever anything else. In 2017, the drillship Joyde's Resolution ran Expedition 371 across the Tasman frontier under Rupert Sutherland and Gerald Dickens. It put cores into 6 sites. At Site U-1508 in the north, there is a gap in the record about 6 million years long. Directly above that gap, the sediment fills with pollen and spores from land plants, southern beech, conifers, ferns, mixed in with shallow water microfossils and the shells of ostracods. Something emergent was close by in the Oligocene. Further south, the cores record the northern Lord Howe, rising to sea level around 50 million years ago. By 45 million, it had sunk back to between 600 and 1,000 meters. That matters because of an argument that has run for decades. Did all of it go under? In 2009, Michael Bunce and colleagues built a reconstruction with a drowning maximum around 22 million years ago. At that point, something like 18% of modern New Zealand's land area was above water. Others have argued for total submergence, with everything alive there now arriving afterwards. The evidence against that is biological, and the best of it is a bird that could not fly. Alan Tennyson, Trevor Worthy, and colleagues have recovered MOA eggshell and bone from the St. Bathans deposits in Otago. The material is 19 to 16 million years old, with at least 2 kinds already distinct from each other. A flightless ratite does not cross an ocean and then diversify that fast. Cory was used the same way for years. Then, in 2007, Michael Knapp and colleagues showed that the genetics of the tree worked just as well if it recolonized later. The honest position is that some land survived, and that we cannot yet draw its coastline. Then, in 2023, the map was finished. Mortimer, Wanda Stratford, and colleagues published the basement geology of northern Zealandia. It was built from rock dredged off the Fairway Ridge near New Caledonia, and from new magnetic surveys of the seafloor. It is the first geological map of an entire continent drawn all the way out to its submarine edges. It found things nobody had counted on. There is a Cretaceous volcanic province of about 250,000 square kilometers out there. Roughly the area of New Zealand erupted between 100 million and 60 million years ago as Gondwana came apart. That is an extraordinary quantity of volcanism to have overlooked. There is a granite backbone 4,000 kilometers long, running from the onshore rock out under the sea. And there is a fault that earlier models had drawn across the Campbell Plateau, now deleted, because the survey went looking and the magnetic signal was not there. The rock that completed that map came up in a dredge bucket, off a ridge that no human being has ever seen, or ever will. Everything else in this countdown is a piece of ground that went under and took its own record down with it. Zealandia is the largest of them by a wide margin. It is also the only one that was never lost, because it was never found. It has been sitting there the whole time. For as long as our species has been drawing coastlines, 5 million square kilometers of continent has been lying a kilometer beneath the Tasman Sea. Every chart we ever made painted over it in blue and moved on. The people who finished that map in 2023 did not discover a lost world. They corrected a mistake that every map before theirs had been making since the first one was drawn. If you want to see more videos like this, click the video on screen now and make sure to subscribe.